More concept 7.1. What are relative atomic mass and relative molecular mass? Now, relative atomic mass, the atoms are very small. It's inconvenient to describe their masses using units like grams or kilograms. Instead, we use the mass of atom, compare the mass of atoms. This gives us relative masses. So in order to compare, you always want to find out what is the smallest mass of all, and then the rest will be how many times greater than the smallest mass. So for example, we compare durian, which is 10 times as heavy as an apple. That's assuming that apple is the smallest unit. If we assign apple to be 1, and durian is 10 times as heavy as apple, we say durian has a relative mass of 10 compared to the apple. Now, carbon 12 is taken as a standard atom, and all other atoms are compared with this standard atom. However, carbon 12 is not the smallest mass of all. Carbon 12 has a mass of 12. If you compare to, why is it so? Because you compare to hydrogen, the smallest mass of all, carbon is 12 times as heavy. So, the relative atomic mass of element is average mass of an atom of that element relative to 1/12 the mass of an atom of carbon 12. Now, why 1/12 carbon 12? Because the smallest atom of all is hydrogen. If we assign 1 to hydrogen, then carbon is 12 times heavier. In order to be equivalent to 1 hydrogen, you need to be 1/12 of carbon 12. So 1/12 times 12 is equal to 1. So if 1/12 of carbon 12, that is equivalent to 1 single hydrogen atom, equivalent to the mass. Alright? So if we take carbon as the standard to compare, then for example, magnesium. Magnesium is twice as heavy as carbon 12. Magnesium is twice as heavy as carbon 12. So if carbon 12 is 12, then magnesium must have a mass of 24. Alright, so in fact, magnesium is 24 times of the 1/12 of carbon 12. Now, relative atomic masses of elements are not whole numbers. Take note of that. The reason is because most elements exist as isotopes. They have isotopes of the same element. So it's a mixture of isotopes that give the average mass, relative atomic mass. For example, chlorine 35. The 35 means the mass of this particular isotope. Chlorine 37 is the mass of this isotope. Actually, don't be surprised when you see the word isotope. Isotopes are just atoms. So I can say that these two, chlorine 35 and chlorine 37, are two atoms of the same element. And we call them isotopes because they are the same chlorine atom but different mass. So if chlorine 35 is 75%, chlorine 37 is 25%, then their relative atomic mass, which is the average of them, will be 75%, 75 over 100 times 35, and 25 over 100 times 37, and add together they will 35.5. So all calculated final answers should be rounded off to 3SF if it's not exact, okay, or above 3SF. If it's exact, like for example 1.2, leave it as 1.2, right? If it's 2, then leave it as 2. Anything that is more than 3SF will round to 3SF. So why relative atomic mass of chlorine is not a whole number? Because chlorine exists as a mixture of isotopes with different masses and relative abundance. Means that there's the certain percentage of each of the isotope. So causing the calculated atomic mass to be weighted average of that mixture and not as a whole number. Now, relative molecular mass. The word molecule tells you that it is not a single atom. So it can be a molecule of an element. For example, O2. O2 is a molecule of an element oxygen. Or it can be a molecule of compound like HCl. Alright? So relative molecular mass of a molecular substance is the mass of one molecule of the substance relative to 1/12 the mass of an atom of carbon 12. So it's good to memorize that. 1/12 the mass of an atom of carbon 12. So MR, which is relative molecular mass, is basically adding up all the relative atomic masses. So for example, ammonia, nitrogen is 14, hydrogen is 1 each, so 3 times 1 plus 14 is 17. And all these relative atomic mass, molecular mass, there's no unit, because relative. Now, since ionic compounds do not exist as molecules, the term relative formula mass is usually used to refer to the relative mass of ionic compound. So do note that relative formula mass calculated the same way as relative molecular mass, and the symbol is also Mr. So Mr has no unit, right? Mr refers to relative molecular mass, also can refer to relative formula mass for ionic compound. So sodium chloride is 23 plus 35.5 is 58.5. There's no unit. Okay, let's look at this question. Now, you have silicon has 3 isotopes, silicon 28, 29, and 30, and the relative abundance is 92.2, 44.7, and 3.1. So whenever given such a question, please check. Add up together, it should give you 100%. So what is the relative atomic mass of silicon? So you know that 28 has 92%. So very simple. The 28 times 92.2 over 100. The 29 will times 4.7 over 100. The 30 will times 3.1 over 100, and average out is 28.13 SF. Remember, no unit. Oh, sorry. This one should be relative atomic mass, correct? AR is relative atomic mass because it's an element. All right, so silicon has two naturally occurring isotopes, 27, 28, and the relative atomic mass is found to be this. So this is the average. So find the relative abundance of each of the isotope. So the total percentage of both must be 100. So very simple, you let the first one be x, the second one be 100 minus x, because total must 100%. And x over, because x percent over 100 times 27 plus 100 minus x over 100 times 28 must equal to the average. So just look out, and the answer will be right at the bottom. Yeah. So answer is actually here is 98% for the 27 AL, and 28 AL is equal to 2%. Yeah, so that's answer below. So determine the relative molecular mass of glucose. So very simple, right? Add up the mass of all the atoms, relative atomic mass to give you molecular mass. So just 6 times 12 for carbon, 12 for hydrogen. Don't need to put times 1 because it's just 1. 6 times 16, total 180. MR here refers to relative formula mass, but basically the sum of all the formula together. So iron 3 sulfate is Fe2 bracket SO4 3. So if you put the numbers multiply correctly, answer will be 400 here. Okay, this is very special. There's a dot here. What does it mean? This is water of crystallization. It simply means 1 unit of copper sulfate is joined to 5 unit of water. So for every 1 unit of copper sulfate, there is 5 unit of water. In other words, it must be add. So the dot means add to 5 unit of water. So the MR is equal to 250. Okay, if the MR of the XCl2 is 136.4, what is the element X? First of all, let's find out what is the mass of the X, the AR of X. So you take the total, minus away chlorine. Each chlorine is 35.5, so minus away 2 times 35.5, give you 65.4. AR, relative atomic mass of X, is 65.4, and the closest, of course, is zinc.